Last video we explained the relationship within this physical system, okay? And we also call this physical system a g of s. We simplify this whole thing into a transfer function, okay? So this g of s we can rewrite into this form, okay? So they are actually the same thing, okay? So if you were to allow me, this is this. I didn't change anything. I just change the time domain to Laplace domain. So this is dt, we change it to ds, et, we change to es. The controller is still here. I put it as k, and then u of s, and then g of s. This is the whole system that I will talk about for the whole video just now. The output and the feedback system, measurement of yt. So with this, our objective is to actually derive our open loop and closed loop system. So what I mean, so you give me a objective is to actually derive kgs over 1 plus kgs, which is a closed loop function for this one. Which in other case, if you were to remember, in your modeling, kg over 1 plus kg, okay, is a feedback loop, taking that bs is equals to 1. So in this case, we assume bs is equals to 1. So you can say that bs it doesn't exist. Okay. The reason why bs is over here is to actually translate whatever ys into something that is corresponding to ds. So it's like translating English, okay, to Chinese, or maybe translating meter to millimeter. So there is a conversion in a certain sense. So let's say if this is 10 meter, you want to convert it to 10 millimeter. Maybe this is a measurement, so it's not a feedback in this sense. You can also say that it's a feedback, but it's just a measurement. But in this case, I was taught that it was measurement, so let's take it as a measurement. So if it's 10 meter, so it'd be like some 10,000 millimeter values, okay, over s, I think. So you just multiply them, and then you'll get that. But nonetheless, we just treat it as 1. Okay, because in future we always do it with 1, so it is simply like an invisible thing, okay, just like a simple feedback loop. It's just to, okay, anyway. So the purpose of this video is actually to derive this, which is also part of our objective, as we say that then we have to derive closed and open loop functions. So therefore, let's start. As you know, E of S is equals to mean input minus output. Okay, input minus output. So you can find whatever power losses that you are talking about. So E of S is the power losses, you would say. If you remember last video, power losses plus whatever change in the internal energy equals to input power. So this in other words, this whole thing is actually the output. Okay, so the output okay, so this is the output. The usable output plus some power losses is equals to input power. Sorry, so I said wrongly. So the usable output, which is using it to actually change something, plus power losses is equals to input power. So definitely input power is larger than output power. So the power losses that is being measured over here when summation, okay, is a measurement of your output. So therefore, the power losses is equals to main input minus the output. So this main input is never the same as this input. This input comes from the controller power output, and this input comes from whatever input that you are talking about from, not in this picture. So power input from controller US. So now we're talking about the power input, okay, not the main input itself. So power input US is equals to K, the controller, and ES, the whatever difference or whatever power losses that you're talking about, or maybe perhaps the whatever value that after you have meet in the summation point. So this ES is, it can be a measurement of power loss, it can be a measurement of the difference. It is actually the measurement between main input and output, that's all. So after that you can feed back into your controller will decide whether you want to increase amount of energy or decrease the amount of energy. So therefore the output, therefore we have cleared this. So the output itself, ys is equals to the us, the power input from the controller, okay? We are talking about the same picture, okay? So the ys is equals to us plus, multiplied by gs. So us multiplied by gs is equals to ys, right? So if you were to sub in the us as es times k, as shown over here, us is equals to kes, okay? K times es will eventually come to us, right? So this is why we sub in this thing into here. This thing into here. So therefore we have kes gs. So all along we are actually trying to set an equation such that it relates to es, ys, and ds. Okay. So our first step here is actually to find an equation for ys, and then we find an equation for ds, and then we rearrange everything equals to es, and then we compare. Okay, so what I mean is at first, okay, so let's continue first and then you will understand. So ys is equals, as we say, ys is equals, okay, ys is over here, ys is equals to the forward loop. Okay, so it's es times k times us times gs. Okay, so it's k e, no, us, okay, sorry, us is in terms of es and times k, sorry. So k e s g s, okay, so it's this one and this one. And es, and you just rearrange es, you just bring k and g in downwards, so you have, over here, es is equals to y. So I have made the relationship between the changes between the input and output in terms of output and some values in the forward function. So this is a forward path. Now we're gonna make an equation that is relates to the input with the es itself. So we sub equation 4, okay, this one, the output, into equation 1. So we sub into here. So therefore, ds, as you know, this one is the error. So the power losses, I would say. Sorry, yeah, error also can. So mean input minus output, right? So mean input is ds, and then output is kesgs, which is kesgs, which is what we are talking about it. So simply you can just rearrange, okay? You rearrange by bringing the k e g s in here, so you just plus equals to our ds. So now we need to factorize out all the es because we have seen es over here. So if you factorize es, you have 1 plus kgs equals to ds. So don't get confused with so many s's and es and whatever. It is just, so this part itself, okay, this portion is saying that the error is taken from your input minus the output. And then the output, how can this output be represented by all these things? It is being represented by this. Okay, so the output is being represented by the controller, the error, or the power losses, and the transfer function. And this us is just a term to translate, to actually convey k and es into gs. So it's just an input, it's just a term only, that's all. Because if you talk if you're gonna talk about components, it's just transfer function and the controller itself. Sorry. So therefore the main input itself can be also rewritten in terms of these equations. Okay, so therefore we did a few stuff. Okay, we rearrange, we factorize, and then you rearrange again. ES, bring down, so it will be the input. Okay, the input going in this manner. We have a forward, have a closed loop back here 1 plus kg, right? So this input itself goes straight down, and then you have a feedback which is also multiplied by 1, because this one is equals to 1, right, as I said earlier. So this is 1 plus kg, okay? So it's just 1 plus kg. If you remember in the old videos modeling how we derived the 1 plus kg, but nonetheless, we are already here. So you just sub in 7 and 4.1, okay? You just sub in 7 and 4.1 because they are in terms of ES already. So you just, YS is this one, and this one is this one. You rearrange in terms of output divided by input, you eventually get this closed loop function, which is kg. This is the open loop. Okay, if you have no feedback system, you are just one straightforward loop down is kgs. While the closed loop itself is the whole system, so it's 1 plus kgs. And how is this related to our poles and zeros? Okay, if you remember, so this is actually our zeros, and this is our poles. So this is why, as I say, this is very important. You have to know this concept and poles and zeros in order to go further. So eventually, a lot of equations will be in terms of this transfer function. In other words, this is a transfer function. We can call this h of s. Okay, equals to, so please do not be confused with my transfer function as I said earlier, this g of s. This one, so g of s is within h of s. So it's like a double, it's like a, something inside something down thing. So I think I've managed to explain it quite well in terms of deriving the open and closed loop system. And then maybe hold on a while. So I'll just stop here. Next video I'll just talk about techniques to using this equation. Okay, this equation. This is our transfer function to identify certain equations. Closed loop or open loop. Okay, so I shall see you in the next video.